Hello everyone, today I'll be showing you guys how to approximate pi using a very simple visual sort of program to, as you can see, it's quite simple. All it does is draw a polygon, one single polygon with n sides, and as n approaches infinity, you can see pi approaches pi. So let me go ahead and create a new file here. So we don't need a draw function. Let's create a canvas and let's make it full height. So I'm going to say window width and window height. So first of all, let's create a function to draw a polygon. Function polygon, and this will take in n sides with a radius of r. So what we can do is we can loop over points from 0 to n minus 1. So that way we get every single point, and then we can use simple trigonometry and get like the unit circle, and we can well, we'll talk about that later. But first, let's create the for loop. So for let's I equals 0, I is less than n plus 1, and then I plus plus. So here we want to get our x and y positions, so we can simply do, since the x position should be, well, r cosine theta, and then y positions, obviously y r sine theta. So let's just do that. So we can do x equals r times cosine. And then you know that the radius of a circle, or not radius, of course, the perimeter of a circle of a unit circle is 2 pi. So what we can do is we can say 2 times pi, and then divide it by n, because that's the amount of sides we have. So we split up each into n number of segments we have here, and then we can multiply it by I, so we get that specific segment that so we can multiply the n I equals 1. I equals 2, I equals 3, all the way around until we go to a full circle. And then we can do the exact same thing with y. So let y equals r times sine 2 times pi divided by n times I. And then here we actually need to, since we want to draw a line from point to point, we can simply create a previous variable where we're going to store the previous. So well, here we're gonna, let's just store the previous one first. So previous equals x is x, and y is y. And then up here we can say if I is not 0, so if we're not on the last one yet, we'll draw a line from the previous to this one. So line from the previous, so previous dot x, and previous dot y. Oh, I said this one's the last one. No, I meant if this is not the first one, because previous is still an empty variable, doesn't have x or y, we didn't set it yet. So we'll draw a line from previous dot x from previous to current, which is x comma y. And that should be it for just simply drawing a polygon. So what we can do is we can, first of all, we need to translate things to the center. So let's say translate from width over 2 to height over 2, so that way everything is centered. And then we can say, let's test this out by saying polygon with, let's say, 3 sides and a radius of 50. And you can see we simply draw a triangle. If we have 4 sides, well, we'll have a square with 5 sides and 6 sides and so on. So you can kind of see where we're going about here. But of course, in able to approximate pi, we actually need to get the distance around here. So what we can do is we can simply we can count for the perimeter. So we can say let's perimeter equals 0. And then over here, we can add to the perimeter. So perimeter plus equals, and there's a dist function, which gets the distance from xy to xy. So prev.x, prev.y, all the way to x to and y. And of course, we need to account for the fact that we have a varying radius, since we don't want to have a radius of 1 pixel, because we won't be able to see anything. So we have to divide by r, and then I think we have to divide by 2 again, since that's not, so we have to divide by 2 here. And then, of course, here we can return our radius. And then let's try printing this. So console.log polygon, and let's see what our radius is. Oops, it's not called radius, whoopies. It is called perimeter, my bad. So return this, and we get 3, which is not very accurate because, well, 6 sides is not that many. It should approach infinity and be able to get to. So what if we had 100 sides? This would look close to a circle. We got 3.1410, which is pretty close. Yeah, as you know, pi is like 3.1415, 29 something something, I don't know. But let's try visualizing this as we automatically increase the number of sides over time. So what we can do is we can we can make a set interval function, so that way it increments it every so seconds. So first let's create a variable for how many sides we have. So let's say let's sides equals, start it off at 3, so that way we get a shape. And then we can set interval. And this takes in a function in which we are going to increase the number of sides. Or actually, I would like to draw it first, so I can put this in here. And then increment the sides. And let's see how that works. Well, sides. Okay, so it's 3.14 polygon. Oh, it's not clearing the canvas, right? All right, so first we have to clear the canvas. That's why it looks like it's so messy here, but we have to say background. Let's say the background to white, so 255. And oh wait, I forgot to add the second parameter, which should be the amount of the increment time. So we are approximating pi. It's not changing though. I'm not sure why. Oh, right. That's stupid. Of course, because I just set it to 100. I have to set this to sides. There you go. And now we got an approximation of pi here, and you can see quite clearly the number is indeed approaching pi. And that's pretty much it. You now made a p5.js sketch simulating a calculation of pi that approximates it. Thanks for watching.